In the last video, we have seen how we can use pipeline abstraction from Hugging Face for performing natural language processing tasks. More specifically, we have seen how to perform text classification tasks. And in this video, we are going to continue that theme and we are going to see how we can perform text generation task using pipeline abstraction. And then we are going to see generate abstraction that comes with all text generation model, and we are also going to see how this compares with the pipeline abstraction. Okay, so because this is going to be a large language model based demo, I don't have GPU and I have prepared this code in Google Colab and I have already executed this using one of the GPUs available in Google Colab. So I'm just going to walk through this code and explain the outcomes. The first thing that I have done is I have installed all the dependencies that are needed for this demo. So we obviously need transformers, and I have installed two additional libraries. The first one is called Accelerate. This is just to speed up the model's performance when we are using GPUs. And then the other library that I have used is this Bits and Bytes. And this library is used for quantizing the model, which is basically to reduce the size of the model when we are loading it up in the GPU's memory. Okay. Then I'm importing all the libraries that I want to import, and I am actually using Hugging Face Hub here to log into my Hugging Face account, and I have this HF token added as a secret in the Google Colab. And this Hugging Face access token can be obtained from your Hugging Face account, and I have simply added that here in the secret. And if you see here, I have created Hugging Face token secret variable here, and the value of this is basically my Hugging Face token, and I'm simply accessing that here. Okay, so with that, I am actually logging into my Hugging Face account. Now, because I have logged into my Hugging Face account, I'll be able to access both private and public models. The reason why I need to log in is because I am using a model called Gemma from Google, and in order to use this model, I need to accept the community license agreement from Google, and I have done that using this account. So I am logging in with that account, so I'll be able to download this model. Once the login step is done, we can actually use the pipeline abstraction to generate text. And as we have seen in the previous video, pipeline is just a function, and we first need to specify the task, and the task is basically text generation. Then we are specifying the model, and the model is Gemma from Google, and this is specifically Gemma 7 billion instruction trained model. And I am specifying this parameter to allow the pipeline abstraction to choose right PyTorch data type. Okay, because the model weights are going to be a floating point number, and there are different types of floating points supported by PyTorch. By setting this parameter, we are allowing pipeline to choose a right floating point type which is suitable for this particular generation task. Okay. Then I am setting this parameter, which is basically a device map parameter, and this parameter allows pipeline to automatically choose the device. If the GPU is available, then it will be used. If the GPU is not available, then it will be using CPU. Okay, so that is what this does, and when I run this, it is going to create this pipeline, and that is going to be assigned into this pipe variable. Then if you see here, I'm creating my prompt. This is the specific prompt template for Gemma. So we just need to follow the right prompt template, and in here I'm actually putting in my question. I'm asking what is Hugging Face, and I'm following the right prompt template suitable for this particular model. Okay, then I'm passing in the prompt and passing in a couple of additional parameters to the pipeline that I have created. When this code runs, this is basically the inference. It is going to run inference with this prompt, and it is going to generate the output text. And that generated output text will be available within this results array. And I am actually taking the generated text from the first item of that array and printing it. And if you see here, this is the generated text. Ignoring the prompt template that we have passed in, we can see that we got this as an output, and this is in the markdown text format. So basically this is exactly similar to what we have done for the text classification, but this time we are using a large language model for text generation. Okay, so but if you want some lower level access, if you want to pass in some additional parameters that are not available directly in the pipeline abstraction, Then we can use the lower level abstraction called generate, which are available in all text generation models. Let's see how that looks next. Like I said previously, this is actually slightly lower level abstraction, so we need to do few additional steps in order to use this method. First, we need to load this model. So this is my model, which is Gemma 7 billion instruction trained model, and I am first loading the tokenizer for this model. And this line loads the tokenizer for this model from the Hugging Face. Then I am actually loading the actual model itself. By specifying the model name here, I'm loading the actual model itself. And while loading this model, I am actually specifying that this is my PyTorch type. I'm saying that I want to load this model with float 16 as a model weight type. And I'm also specifying the device map as auto, which means the model will use GPU if GPU is available, otherwise it will use CPU. Okay. So now we have the tokenizer and we also have the model. The next thing that we need to do is we need to create the prompt, just like what we have done previously for the pipeline abstraction. So the prompt itself is not going to be different based on the way we use, whether it is actually pipeline abstraction or generate abstraction. The prompt itself will be same. But because we are not using the pipeline abstraction, we need to tokenize the prompt explicitly. And we have created the tokenizer here. With that tokenizer, we are actually tokenizing this prompt. And we want the tokenized results to be PyTorch tensors. And that is what we are actually specifying here. And this input will be tokenized prompt in the format that is compatible with PyTorch. Okay. Then I am moving this input to GPU if the GPU is available. And then we are calling the generate method available in the model itself. Okay. So this is the generate abstraction. Like I said, this is actually slightly lower level than the pipeline abstraction, and which means we'll be able to control some additional parameters that are not available directly in the pipeline abstraction. So one of the things that you can see here is actually we have something called top P. This was not available in the pipeline abstraction. So these kind of lower level parameters can be controlled by using this generate abstraction. And in addition to that, we can also do some pre-processing with the prompt, and we can also do some post-processing on the output. And we will not be able to do them if you are using the pipeline abstraction. So when this code runs, you can see that we are getting the same result or similar result that we have seen previously using the pipeline abstraction. So hopefully this helps you to understand how simple the pipeline abstraction is for any particular task. And if you don't want to use pipeline abstraction for any reasons, if you want to go a little bit deeper, Hugging Face allows us to do that as well. Especially for large language model, we can use generate method to achieve that. Okay. So that is all I wanted to show you in this video. I hope this is useful. Thank you.